Google's AI overview is lying to you about the jellyfish on Mars by misleading you about cosmic rays. This seems like a strong statement, but actually, we can prove it pretty easily. A few days ago, we uploaded a video explaining that the Mars jellyfish anomaly was very likely to be a cosmic ray artifact due to the presence of a row of clipped pixels with no anti-aliasing, a sure sign of an imaging artifact. Real objects, even alien spacecraft, don't produce that. I explained the mechanism for how a cosmic ray can create an artifact on an image sensor and explicitly showed how if it impacts during a calibration frame, the subtraction can produce a black artifact on the final image. I then provided an independent confirmation of this in the form of the Mars Science Laboratory camera engineering lead explicitly describing this exact process, producing a black artifact in an image from a few years ago. Despite this, I saw a surprising number of comments that confidently and incorrectly insisted that cosmic rays can only produce white artifacts, never black. Here's a few. Quote, as I understand it, and if the supposed experts are really experts who know what they are talking about, cosmic rays are never black. You may be an astrophysicist, but you definitely aren't a photographer. Cosmic ray hitting a camera sensor would not leave a black spot of multiple pixels. It would excite the sensor, leaving a bright white spot, and it would be permanent. Quote, I have never seen a black cosmic ray artifact. It is always white. I responded to each of these and more, reiterating the dark frame explanation from the video. But it did get me wondering, why are there so many people repeating this incorrect thing so confidently? I scratched my head about it for a while, but I didn't get a clue until a friend texted me something alarming. He had Googled a question about cosmic rays, and Google gave him an answer that conflicted with my own. I was frankly shocked by this. Cosmic rays creating black artifacts due to subtraction of calibration images is a very well-known and understood effect. It was not only confirmed by the MSL lead camera engineer, but it's even reproduced by amateur astronomers, like this thread on cloudy nights where Alpha Triple Plus says, quote, if you use a master dark for calibration that has a cosmic ray hit, the calibrated lights will probably exhibit a wiggly black streak as the hot pixel streak in the master dark is subtracted from every light in the live stack. Happened to me just last night. So why did Google's AI overview get it wrong? I decided to investigate a little. I tried my friend's query and was able to reproduce what he saw. Asking, quote, do cosmic rays cause dark artifacts caused Google's AI overview to confidently say, no, cosmic rays do not cause dark artifacts, even bolding and highlighting the wrong answer. I even tried asking a few different ways, asking specifically whether cosmic rays can cause dark artifacts when impacting on a bias frame, wrong answer still, or even going as specific as asking, if a cosmic ray strikes during calibration image acquisition, can the final image have a black artifact? Wrong answer again. But after a few prompts, I did notice something interesting. Even though it always highlights and bolds the wrong answer, sometimes buried down deep in the answer is the right answer, which it for some reason didn't feel was important enough to point out. For example, in the very first prompt, can cosmic rays cause dark artifacts, while it highlights and bolds its no answer, it has a section below titled, What Causes Dark Artifacts, where it explicitly says that subtracting a master dark frame can create dark holes or negative spots if a hot pixel is not active during the actual exposure. That's literally the explanation I gave in the original video, where the hot pixel is caused by a cosmic ray and the correct answer to the question. But it's buried down in the answer for some reason. However, seeing this right answer pop up in the response, just buried, gave me an idea about how to get it to give the right answer. If you ask it specifically, what artifact does a cosmic ray in a dark frame create after dark subtraction, it will give the right answer, a negative pixel or a black hole / spot in the resulting calibrated image. So, if you used AI to validate your comment by just Googling and reading the first line in the Google AI overview, I hope this clears that up. It's just a logical error from Google's AI overview. And I hope this makes it clear that AI makes mistakes very frequently, and it is always better to try and dig up the answer yourself or talk to an expert versus blindly accepting an AI's answer at face value, especially if the question is in a field that isn't your own. You have to be careful about interpreting responses from any AI, as exemplified by this problem we and you may have encountered trying to use AI to understand a subject as complex as image analysis of an optical camera in a very harsh planetary environment. For the record, I tested this problem on ChatGPT and Claude as well on the weakest models to give AI overview a fair shake. ChatGPT made a similar error, but put the right answer right near the top, so I would consider that a success. If you don't read one sentence down, that's kind of your fault. Claude just got the right answer out of the box. This seems to be an issue with Gemini relying too much on the fact that cosmic rays are most often associated with bright artifact, but it's a perfect example of how LLMs, which may assume the correct answer is the one most repeated in the training data, can be deeply flawed if not paired with careful reasoning capabilities and primary sources. This also leads into something else I want to discuss, which was another theme in the comments. If AI's answers may need heavy interpretation, and to be clear, the answer is they do, what can you trust? More importantly, I realize that I'm pitting myself against Google here, which has vastly more knowledge than I have. Why should you trust me over Google Gemini, a powerful frontier AI model? I saw this question raised many times in the comments. One common theme was the idea that astrophysicists don't know anything about imaging, or insinuating that astrophysics and imaging/sensing/photography are somehow disjoint, mutually exclusive fields. If you think this, I can of course understand why you might be hesitant to trust my explanation when Google is very vehemently telling you the opposite. So I wanted to dive into this a little bit. First, you don't need to trust me or Google at all. All of the analysis in the previous video is analysis you can do yourselves. You can check the pixel values and see they are either 000 or 111 in the region of the artifact. That's classic clipping. You can see it goes from pitch black to sky white with zero anti-aliasing, a sure sign of a sensor glitch. And if you think that I, as an astrophysicist, am not qualified to weigh in here, I showed an email from the lead engineer on the MSL camera explaining a similar black artifact as a, quote, textbook cosmic ray. And I assure you, the lead engineer for the MSL camera is indeed an expert on imaging. But I would also like to speak up in defense a bit of astrophysicists everywhere. Reading comments like this, I feel like there is a severe misconception about what astrophysicists do and where our expertise lies. The vast majority of astrophysicists are observational or experimental astrophysicists, and while many of us, including myself, spend a lot of time working with theory and with theorists, most of our work is done on data captured via imaging. How do you think we study the stars? We can't exactly go to them. We mostly just take pictures. Sometimes fancy pictures, like what a spectrograph does, or pictures in non-optical wavelengths, like what radio telescopes do, but they're just pictures, and we analyze them and extract data from them. Even if you don't specialize in imaging, you almost certainly know fundamental principles of imaging and the details of the instrument you work on specifically, and these fundamental principles and many instrument details are shared across almost all imaging instruments. Many of us work at observatories directly and have our hands on the raw data flowing in from the telescopes. Some of us, in this case not me, but like my Astroveo colleague and good friend Dr. David James, have built the telescopes and cameras on these mountaintops with our bare hands. While I mostly work with observational data and how we can use that data to test our various theories, David literally built this enormous telescope on top of Mauna Kea in 2010. Here is Dr. David James himself to say a few words about his thoughts on this anomaly.
Hello there. Welcome to the Warpack mountain range in southern New Hampshire. For regular viewers of our channel, you will know that I've spent the past 30 years or so as a professional astronomer and astrophysicist. I have built many telescopes and indeed astronomical instruments all over the world. Oh, hello there. On Hawaii and in Chile and in the Canary Islands in South Africa. And I have looked at possibly tens of thousands of astronomical images. We have a friend. What a lovely choice. What a lovely moment. I'm going to keep recording because I'm in nature and that's why I was here to see some beautiful wildlife out here. I've built these astronomical cameras, I've built these telescopes, and I've looked at tens of thousands of astronomical images. And what you find is that the human brain loves seeing patterns. I happen to be pretty good at it with spectra. I'm pretty decent at spotting single stars, binary stars, lithium lines, all kinds of interesting things in stars. But occasionally, just occasionally, I see things that I want to see, especially if I hadn't had a cup of tea, or I'm tired, or that crow is deciding to distract me. Well, this phenomenon, this pareidolia phenomenon, in which humans make random shapes, or seemingly familiar shapes even, out of things they see in nature or in the environment around them. A good example being lying on your back in the forest and looking at the clouds and seeing a cloud or a car or a mountain or whatever. That's very, very common, and it's actually you see it throughout human history in terms of the literature, in terms of oral stories handed down. And so this jellyfish on Mars story rings true of that for me. We end up seeing what perhaps we want to see. Now, in astronomy, this is not unusual. In fact, there are at least three, many actually, quite famous examples of pareidolia. For instance, in 1976, the Mars Viking 1 orbiter took a photograph of Mars at quite low resolution and in fact saw what looked like at least a human face. Well, years later, there was another orbiter took a very high resolution image of the same area, and that man in the face on Mars image just turned out to be an eroded rock. We wanted to see a human face. We were like, oh my God, look at that, there's life on Mars, it's a big human face in the sand. Well, of course, the other one is the sort of famous man in the moon story. You look up at the moon and you see those dark areas, the Maria, the old volcanic plains of Mars, of the moon, and of course it looks like a human face. Some people say a rabbit or a mouse. I don't see it actually, but maybe the Moadib if you've read the book Dune. But the sort of human face I can see. I'll see that myself. Certainly saw it as a child when I looked up at the moon basically every night and just sort of dreamed of being an astronomer. And the ultimate, perhaps, pareidolia in astronomy are the constellations themselves. The ancient Greeks and the ancient Persians saw all kinds of interesting shapes in the sky, and they fancied stories around the patterns of stars they saw. That doesn't necessarily mean that Orion really is a hunter with a sword and a shield and was placed up in the heavens by Zeus. So I think you've got to be really careful when you look at things like images of Mars, on Mars, taken with a fairly low resolution camera. Its angular resolution actually is really quite poor. It's about, let's see if I can do the numbers in my head here. It's at least 200 times poorer spatial resolution than most astronomical cameras here on Earth when we look out at stars and galaxies and so on. So its spatial resolution is terribly, terribly poor. And I can tell you from first-hand experience that the images, the artifact that you saw, that one sees, and that image that was released by the Mars Explorer team, looks awfully familiar. And I've seen tens of thousands of these kind of events during my career. It's either a cosmic ray-like event, probably a calibration frame actually. Cosmic ray events are almost always brighter because they dump energy into the CCD detector, the charge coupled device detector. Oh, that's beautiful. Oh, look at the wingspan on that. Holy cow, sorry, I got distracted by a very beautiful bird flying off. And so these cosmic ray events are actually not that unusual at all. They do tend to dump energy in, so one might expect a brighter streak. However, if that cosmic ray were to dump its energy into a calibration frame, and that calibration frame be subtracted from the images, it would look like a dark or a black streak. That is not that uncommon. It happens. Image processing, those images we're seeing are not raw images, not coming straight off that low resolution camera, the right navigational camera on that on Curiosity. So I think probably what's happened is it's either a miscalibration, so somebody has either somebody or the algorithm has not done the calibration frames quite right and has subtracted what is probably an erroneous master calibration frame, or it's probably an image artifact. So I really do think that this sort of Mars jellyfish, the most sensible, probable answer is the fact that it's either a cosmic ray event in a calibration frame, or it's an artifact from the image processing software on the Curiosity rover itself, or at least the uplink to the orbiter. Does that mean it's 100% guaranteed to be one of those two reasons? No, but at least it has some basis in science that would explain what we see. All of the hypotheses are somewhat ad hoc, and unless one has evidence to the contrary, it really is then just, oh, I believe it, or I think it's this, or I think it's that. Anybody can believe whatever the heck they want to believe on this thing. But probabilistically, if you were to do a serious analysis, it would I think the least likely explanation would be extraterrestrial life, especially in the form of a floating jellyfish. You also have to take into account, by the way, that if NASA engineers saw something like that, they would have released it themselves and they would probably be winning the Nobel Prize. It would be a civilization-changing level event. If we were to detect some form of extraterrestrial life on essentially the planet just next door, that really would change the face of humanity, let alone science. So for that to be kept secret, I don't think that's realistic. To keep an entire cohort of NASA engineers quiet about having detected extraterrestrial life from one image that has what looks like an image artifact or perhaps a calibration issue, that's just not realistic at all. And so I think the most simple explanation is probably the most realistic one. And so for my money, especially with my experience in optical imaging and building instruments, I think it's probably a calibration effect or maybe an image processing effect. When I looked at that image, the last thing I thought of, oh yeah, that looks like a jellyfish. Now, to be honest, the very first thing I did think of is it looks like an Imperial probe droid from The Empire Strikes Back on Hoth. Looks almost exactly like that. But that's, again, my brain wanting to do Pareidolia because I'm a big Star Wars fan. So again, really, I think Joseph did a really nice video in the first place. He sort of explained that it's really tempting to see what you want to see in these astronomical images. I do it myself. Look, even in the forest, I'm panning around here. I see all kinds of beautiful things here that I could think, oh God, look at that. Especially as the light is starting to fade a little bit, your human imagination takes over. But we are professional scientists. And so whenever we think of, we want to have explanations for things we cannot explain, we almost always start from a scientific basis. Is that a reasonable thing to assume? And if it is, can I prove it? And if I can't prove it, can I rule other things out using the scientific method? And again, a jellyfish on Mars is really, really hard to prove, but fairly easy to disprove. And so I think that's the most sensible way to go on this type of thing. I do support Joseph in the fact that he did a really nice job in answering the comments in the original video. He took into account all the comments, and this is the genesis of this video. The second video is we're really trying to address our viewership who are saying, well, what about this and what about that? That's the nature of being a good scientist and having good communication of science with the public. It's sort of an obligation of ours to engage the public and say, hey, if you've got scientific questions, we'll try our best to answer them. We may not always be correct, but we'll try our best and we'll do it from a scientific basis, not from an ad hoc, oh, it could be this or it could be that. Then that doesn't really make us scientists at that point. And so we've spent our entire careers developing the scientific method for ourselves to maybe ask the right questions. Do we always get it right? Absolutely not. We make plenty of mistakes. But that's the beauty of science. You make mistakes to improve the science or to improve the reasoning of what you think you can see. But that's my 2 cents from a mountain in southern New Hampshire. I hope you enjoy it, and I'll catch up with you all soon. Happy stargazing.
So the separation that's being drawn between astrophysicists and imaging is not a very good one because that line is very blurry. So if you're wondering who to trust and your choices are between astrophysicists or AI, particularly the Google AI overview, I hope this gives a bit more info for you to make your decision. Thank you for watching. Don't forget to like and subscribe if you like debunks like this. We'll have more coming soon.